Good morning to one and all. In the previous lecture series, we have discussed about the needs of non-traditional machining process and what are the various different types of non-traditional or unconventional machining process. In this video lecture series, we will discuss about one of the type of non-traditional machining process, that means electrical energy based unconventional machining process. Now we are going to the topic electrically energy based process. In electrical energy based process, electrical energy is directly used to cut the material to get the final shape and size. Some of the examples of electrical energy based process are electrical discharge machining process and then wire cut electrical discharge machining process. This is the 2D diagram of the electrical discharge machining process, EDM. Here the spark between, this is the simple 2D diagram. I will look into the image. This is the fixture and this is the work table and this is the electrode and this is the dielectric pump, filter, and the dielectric will pass it to that of the electrode with the help of the filter, and this is the tool holder. Is the part is the DC pulse generator. One end is connected to that of the tool, that means positive, and then the minus is connected to that of the workpiece, and the dielectric fluid is made to pass through the tool with the help of through the filter. Here the spark is produced between the electrode. Dielectric flushes the metal powder. It can is inexpensive, precise, complex shapes can be produced with the help of the electrical discharge machining process. This is the power supply. This is the current control. This is the servo motor. The servo motor is used to feed the tool. Either it can be, it is a movable electrode. It can be moved leftwards or rightward directions or upward or downward directions. This is also another diagram of the electrical discharge machining process. Here we are going to discuss about the working principle. In EDM, it is also known as the spark erosion machining process. It is the metal is removed by producing powerful electric spark discharge between the tool and the workpiece material. As I had already mentioned, the tool here acts as a cathode and the workpiece material here acts as the anode. When the DC supply is given to the circuit, spark, its temperature of about 10,000 degrees Celsius is produced across the gap between the tool and the workpiece. At this high pressure and temperature, workpiece metal is melted or it is eroded and some of it can be vaporized. In this way, the metal is removed from the workpiece. While we look into the diagram, here the cathode minus is connected to the tool and the anode is connected to positive terminal, negative terminal is connected to that of the tool and the positive terminal connected to that of the workpiece material, and it is immersed in the dielectric fluid surface. When the power DC supply is on, there is a spark, electric spark of about 10,000 degrees Celsius is produced between the tool surface and the workpiece material. As the heat is generated between the tool and the workpiece, the metal get vaporized and the final shape can be attained. The function of the servo motor and gearbox is to move the tool according to that of the required shape. Next, we will discuss about the construction and working of the electrical discharge machining process. Some of the major parts are electric power supply, DC supply, positive terminal and negative terminal, and then the dielectric medium or dielectric fluid, workpiece, tool, servo control mechanism. Here the workpiece and the tool is directly connected to that of the DC power supply, and the workpiece it is connected to the positive terminal of the electric source, and the tool it is connected to that of the negative terminal of the electric source. Tool and workpiece is submerged in the dielectric fluid medium. Some of the dielectric fluid are paraffin, white spirit, transformer oil, petroleum based hydrocarbon fluids, kerosene, mineral oil, etc. As it, why dielectric fluid is used is it has a poor electrical conductivity. And then a servo mechanism is majorly used to maintain the small gap in the range of 0.005 to 0.05 mm between the tool and the workpiece. Working. When the DC power supply is on, spark produced between tool and the workpiece, and the voltage of about 250 volt is produced. This spark occurs in an interval of 10 to 30 microseconds and with the current density of 15 to 500 ampere per mm square. So the temperature rises of about 10,000 degrees Celsius. Therefore, high pressure and temperature the metal is eroded or melted and vaporized. Then the removed fine particles or chips can be carried away with the help of the dielectric medium. The metal removal rate depends on the spark gap maintained between the tool and the workpiece. Next, we will discuss about the dielectric fluids and the tool material. Some of the dielectric fluids are kerosene, mineral oil, paraffin, hydrocarbon fluids, deionized water, etc. The major function is it acts as an insulating medium. It cools the spark region and helps in keeping tool and workpiece cool. And also it carries the eroded particles along with it, and also it maintains the gap resistance across the gap and removes electrically non-conducting until the required voltage is reached. Next, what are all the electrode materials we are using in the case of electrical discharge machining process? The metallic materials are copper, brass or copper tungsten. Non-metallic materials such as graphite is used, or else combination of both metallic and non-metallic materials can also be used. For example, copper, graphite. Advantages: it can be used for machining various materials such as tungsten carbides, electrically conductive materials, etc. It gives good surface finish and machining of very thin section is possible. Fine wools can also be drilled with the help of EDM, and also it is a quicker process. Some of the disadvantages are non-metallic particles such as plastic, ceramics cannot be machined with the help of EDM. It is only suitable for smaller workpieces. Perfectly square corners cannot be made with the help of an EDM. Applications: thread cutting in jobs, drilling of micro holes, helical profile drilling, curved hole drilling, resharpening of cutting tools and broaches, etc. This is some of the diagram which is produced with the help of an EDM machine. Thank you.